Hello, I'm Suresh Kumar Kirubagaran, a Master of Earthquake Engineering student at the University of Auckland. Today is 2nd of August 2025. I am here at 203 Broadway, Newmarket, Auckland, conducting a site inspection of the two-story clay brick unreinforced masonry building. This video recording is part of my site inspection report for the Civil 745 seismic assessment of existing building course. In this inspection, I'll describe the building, highlight any observed changes and potential hazards, and record key measurements for later analysis. The site is generally flat at street level, without any nearby steep slopes or embankments. Drainage and curbs along the streets are well planned. There are no geological hazards from neighboring hills, such as rock slides or landfills. I found no evidence of exposed rock, liquefaction, or lateral spreading. Based on these conditions, we will adapt site soil class C for the subject building. The subject building is a two-story unreinforced masonry structure forming part of a continuous row of shops with minimal setback from neighboring properties. On the left side of the front facade, there is no adjoining building. As the site is separated by T Street, on the right side, there is nearly zero setback to the neighboring property. Looking at the left facade, which faces Teat Street, the right side of the facade is free with no adjoining building, while the left side is very close to a neighboring structure. These conditions create the possibility of structural bonding, especially at the parapet level, where roof height differs, increasing the risk of differential movement. Overall, there is no risk of debris falling onto the building from neighboring structure. In summary, the subject building has minimal gaps with neighboring structures. On the right side of the front facade, facing Broadway, a gap of nearly 10 mm is observed at the bottom between the buildings, gradually increasing to approximately 15 mm at the top. This gap is sealed up to half the first floor height with no adjoining structures above. On the left side facade, facing Teat Street, there is almost no gap up to the first floor level, with no building above that. The right side and rear sides were not accessible during the inspection. During the site visit, direct access to the roof was not possible. However, with permission from a nearby building, I was able to record a video of the roof. The roof is a gable type, sloping towards both the left and right facades. There are several pieces of equipment on the roof, including a chimney. While the equipment makes it difficult to take clear photographs, it is still evident that a chimney is present. It is also clear that the gable-shaped parapets and other parapets are freestanding cantilevers from the roof, with no visible bracing. With many renovations and layers of paint, it is difficult to identify the lintel type at present. However, arcade images show that the lintels above the first floor windows are decorative, made of vertical bricks. These lintels appear to have a depth of approximately 4 courses of brickwork, around 400 millimeters, and are assumed to extend across the full width of the wall. It is also assumed that the longer openings at the ground floor level are supported by concrete lintels. Examining the wall morphology, the outer wall appeared to be two-leaf masonry laid in stretcher bond. This is not immediately obvious on site, as the facade has been modified with a paint or a thin plaster coating. However, the bond pattern can be seen on close inspection and is clearly visible in historical photos. The interior walls were not accessible during the visit. For reporting purposes, they are assumed to be two-leaf solid masonry walls as laid in a stretcher bond pattern. The subject building has been well maintained and has undergone multiple renovations at regular intervals. The ground floor walls are predominantly covered with plaster and paint, which obscure the original masonry. Although the bond pattern on the first floor wall is visible upon closer inspection, determining material properties at the height is challenging. Therefore, for this assessment, the mortar hardness is considered as medium, while the bricks are assumed to be hard. The diaphragm of the building is assumed to be in good condition. It is considered that the timber is free of borer, with little separation of the floorboards, no signs of past water damage, and minimal or no nail rust. Floorboard to joist connections are assumed to be tight and coherent, with no wobbling. The diaphragm is assumed to resist loads parallel to the joist, and the joists are assumed to be continuous along the span. To conclude this site inspection, the subject building is a two-story unreinforced clay brick masonry structure. The material properties required for the further assessment have been identified and where necessary assumed. Thank you.